Example 32. A bicyclist of mass 65 kilograms rides into a 3 meter per second headwind at the rate of 10 meters per second. The frontal area of the cyclist and bicycle together is 0.35 square meter. The drag coefficient is 0.9 and the coefficient of rolling resistance is 0.008. Determine the power required by the cyclist in watts. Assume density of air at 1.205 kg per cubic meter and the mass of the bicycle of 5 kilograms. So power is force times velocity, but this force consists of the drag force and the force of rolling resistance times the velocity of the bicycle, which is 10 meters per second. However, the drag force is a function of the velocity, relative velocity of wind and the bicyclist, because the bicyclist is riding the bicycle into a 3 meter per second headwind. So the velocity, relative velocity would be 10 plus 3 or 13 meters per second. So the drag force is coefficient of drag, density, area, velocity square over 2, where the velocity is equal to 13, 10 plus 3. So substitute 0.9 times 1.205 times projected area 0.35, then quantity 10 plus 3 square over 2. So the drag force is 32.07 newtons, while the coefficient of rolling resistance is just the rolling resistance, Fr, is just coefficient of rolling resistance times the normal force. And the normal force is simply the weight of the bicyclist and the bicycle combined. So it is coefficient of rolling resistance times normal, but the normal is the weight, or mg. So Fr is 0.008 times 65 plus 5 times 9.81. So Fr is equal to 0.008. It is repeated, but the value is 5.494 newtons. And substitute here. Power is 32.07 plus 5.494 times 10. So the power in watts is 375.6 watts.